relationship to microservices. My job today of introducing the speaker is really easy. I think most of you already know him. He is Mr. D&D Tools. He works for Parameterised. I should add, Neil, if you don't mind, if you were not present just before the keynote, he got the first ever leadership OSGi Leadership Award for individual contribution. So that's spanking new. That's what we And as most of you know, he's a good speaker and a teacher, and he's going to talk to us about microservices and the upcoming Java-RS whiteboard service, amongst other things.
Something like that, yeah.
Over to you.
Thank you. So my title, by the way, this is a tutorial in how to get a conference talk accepted. Put the word microservices in your title twice. And if you can, put Docker in there. I failed on that this time, but at least in 2016, this is the way to go. So dynamically assembled REST microservices using JAX-RS and microservices. So, introduction. What are microservices? Now, there's been some argument about this, and we've had some arguments about it with the, for example, the OSGi BOF last night, in that, okay, so we've been using the term microservices ourselves for quite a while before the industry came along and essentially stole that term from us. And I think what we have to do is move on and say, okay, there is this commonly accepted term in the industry, and we have to accept that that's happened and look at how OSGi fits in with that. And it turns out that OSGi is actually a really good technology for implementing microservices in Java. So let's ignore the whole, OSGi services are microservices already kind of argument and look at what the common understanding of microservices is. And this comes originally from some blog posts by Martin Fowler and James Lewis and a few others. So commonly understood to be small, independently deployable units of functionality, decoupled from the internal details of other pieces of functionality, resilient to failure, and potentially implemented in heterogeneous languages. Now, I don't think that's necessary to implement in every language you can think of, but it carries that potential. So I talked about isolation a little bit in my Java 9 talk in the morning. And I talked about how isolation is a continuum. You know, I can have increasing levels of isolation between the components in my system. And as I increase the isolation, I also increase the cost. So going all the way down from sort of monolithic methods and classes down here, up through OSGi, which is an in-process isolation mechanism, a code-level isolation, up through process and container isolation, and then way up through VMs, physical servers, regional data centers. And as I joked in the morning, you know, possibly the most isolated ever thing could be when Elon Musk puts a data center on Mars. Because then it's completely isolated from any extinction level events that may happen on Earth. So what we're talking about with microservices tends to be around here, container / process. And container, in my mind, is just very slightly than the process, because with something like Docker, I can apply limits onto a container that I can't quite do with a process. Excuse me. So if we're talking at that level, then we're implicitly talking about communication between these things that involves networking. Even if it's, of course, two processes on the same machine, we have IPC, which is a form of networking which requires serialization, deserialization, addressing, and so on. And there have been many, many approaches to this problem over the years, going from Corba, RMI, COM in the Microsoft world, SOAP. I think we all have kind of nightmares about SOAP. DDS, and then a bit more modern stuff like Thrift and Avro and Google Protocol Buffers and so on. So there's been a lot of approaches to this. But one of the most common and now fashionable ways of doing this is so-called RESTful microservices. So REST representational state transfer comes from a dissertation by Roy Fielding, and it's an architectural style that focuses on resources over procedures. It focuses on a limited set of operations, typically your kind of CRUD operations, create, remove, update, create, replace, update, delete. Create, read, update, delete, sorry. Flexibility and adaptability. So the ideal with REST is that I can write a server and a client and change those things, and the client should be able to adapt to the changes that are made on the server and vice versa. And REST has good compliance with web and internet structures, things like proxies and firewalls and so on, because it's essentially how the web works. You can see a web browser as a REST client in many ways. So it does play nicely with things like caches and proxies and so on. And REST does not dictate message formats. So the clients can request any preferred format for the data that they like. Many people think that REST is based on JSON, but JSON is just one potential representation. REST can come in multiple representations, and the client can request whatever representation it wants. Of course, the server may or may not be able to offer that representation of the data, but it should be able to do more than one, hopefully. So the advantages of REST versus something more traditional like RPC, very good cross-language support. You know, I can write REST services and REST clients in Java, in JavaScript particularly is quite easy, .NET and so on. The methods that we call have very well-defined behavior. When you're writing an RPC client or an RPC server, you have to think a lot about your distributed application design and things like idempotency of methods and so on. And that has to be documented. What happens if I call a method and it times out? Is it going to be valid for the client to just retry that method on an RPC? It may or may not be. But with REST, we have a certain very limited number of verbs that we can call, and it's well defined what the effects of multiple invocations would be. And so we always know what we can do in that kind of situation. Adaptability, so easier for the client and the server to evolve and deploy independently. So the theory of REST is you could have these kind of unversioned, self-documenting APIs. So REST API should be fully discoverable via hypermedia links within the resources to all other parts of the API. And so all the client should need to know, in theory again, is the entry point into that API, and then they can use standard REST methods and hyperlinks within the resources to discover the whole of the rest of the API. Well, there are some disadvantages to REST versus RPC. It has quite a high impedance mismatch with the mainstream languages. You know, writing RESTful services, and particularly clients, is actually quite a lot of work. And it doesn't match well with the traditional procedural languages that we've been using. So RPC is actually quite quick and easy for getting things running quickly. Because I can just slap in a bit of RMI or something like that, and it works very quickly. I don't have to think too much about the distributed design. Of course, that's a flaw as well. If I don't think about it, then problems sneak in. In practice, so I talked about the theory of REST APIs being fully discoverable and in theory not needing to be versioned. In practice, they always are. If you go and look at a REST API out there on the internet, the Docker API, the GitHub API, things like this, much to Roy Fielding's disgust, they are always versioned. And they document all the methods that are available, all the resource paths that are available. And in practice, clients do tend to depend on specific versions, or at least minimal versions. And they quite often break if they find that a field that they were expecting to be there isn't there because they're on the wrong version of the server. So the ideal of REST is that we have this ability to constantly evolve the client and the server independently, because that can be quite fragile with RPC. With RPC, you tend to have to make sure that the client and server are exactly in lockstep with the version. With REST, it should be more flexible, but sometimes it isn't. because ultimately, if you want to code a fully flexible, adaptive client to a REST API, what you've got is a web browser. It's not really a practical programmatic client.
Have you ever seen one? I haven't. It's not only a lot of work, I have never seen one.
Yeah, yeah. I mean, I'm theorizing that it would be a lot of work,
It would be one, okay.
which I guess is why I haven't seen one.
Yeah, okay.
Yeah. Okay. So let's talk about JAX-RS. So I said that writing REST services has a high impedance mismatch in mainstream languages, including in Java. So JAX-RS it stands for well, it doesn't quite stand for, but it means the Java API for RESTful web services. And it eases the impedance mismatch for writing REST resources in Java. It's a Java EE specification, starting with Java EE 6. It was first defined in 2009 by JSR 3.11, and then it was later refined in 2013 with JAX-RS 2.0. Again, a bit of an odd bit of versioning here because it's backwards compatible and yet has a breaking change in its version, but let's leave that to one side. So they added a client API, standardized client API in JAX-RS 2. They added asynchronous HTTP on the server side, and they added some filters and interceptors, which are useful for doing things like security and so on. Excuse me. So JAX-RS allows us to define resources as plain Java classes. And on these resources, we put annotations. So @path specifies a relative path for the resource or a method within the resource, which gives us a sub-resource. These annotations here, which map to HTTP methods, the verbs that we can use in standard HTTP, so get, put, post, delete, head, and options. We put these annotations on a method, and we can specify produces and consumes to specify the types of data that we can consume and produce from each method in the resource. It's a simple example here. So I have a resource class called foo. Path is foo, so this is the top level path of this resource. And if I add a path to a method here, getFoo, I'm defining a sub-resource within this. So foo/test will give me the string hello. And I'm specifying that this method produces plain text. So text/plain in MIME terms. This one has exactly the same path. The bottom one has exactly the same path, but it produces a input. So it produces JSON. And how do you distinguish between these? Well, it depends which accept header is sent by the HTTP client. So the HTTP client can send accept application/JSON, and this method will be invoked. Of course, it could send an accept header which the server doesn't support, in which case that would return I forget which error message, 405, something like that, unacceptable. But yes. You can also parameterize the path. So I can specify a path with this curly brace syntax here. So test/curly brace name. And so name is now a parameter. So when the HTTP client comes in with the path test/Neil, the parameter into this method, which is indicated by this path param annotation, will be bound to Neil from the path. Okay. JAX-RS also defines a limited form of field injection using the @context annotation. So we can inject things like HTTP headers if I want to look at the detailed headers that were sent from the client, or URI info, which allows me to do things like building relative URIs to my current invocation URI, and so on. One of the more powerful features of JAX-RS is automatic transformation. And this is supported out of the box. You can supply your own transformers, but it's supported out of the box with JAX-B, which is included in Java 8. So I can say produces, here I've got a list of things that this method can produce. So application JSON and application XML, and I'm returning a product object. I'm not returning a string or a stream or anything like that. I'm returning a product object. And this product object will require JAX-B annotations on it, but if I have those, then JAX-RS will automatically map the returned object, the returned product object, to either JSON or XML output, depending on what the client requested. Okay, so how do we do JAX-RS in OSGi? Well, lots of people have tried this, tried to do this directly. The way JAX-RS is designed is a little bit, it's the Java EE way of thinking rather than the OSGi way of thinking, which means a lot of referencing class names, using static methods and so on. So it's a bit tricky. Now, we could use the web application spec, so we could write a WAB. But when we do that, we lose a lot of the other OSGi goodness, like declarative services or blueprints, something like that, for managing the life cycle of components. So what we'd like to do is just to say, well, let's map an OSGi service to a JAX-RS resource. And it's a fairly obvious idea, so many people have independently come up with it. The idea is that I just publish a resource as a service, and it gets mapped to a JAX-RS resource. And this is the OSGi whiteboard style, so it's a very common pattern. You've probably come across whiteboard pattern before. So there have been several open source implementations of this idea. There's one that I wrote, is now obsolete. I didn't maintain it. Most notably in the open source world, there's this OSGi JAX-RS connector developed by Eclipse source. But it's time to standardize this thing, because a lot of people are doing this. We want to do this in OSGi en route. It's a very common thing to do. And it's a good idea to take this spec that exists in the Java EE world, which is quite a nice spec, and support it in an official way in OSGi. And also apply some of the latest techniques and lessons that we've learned from en route into that standardization. So we have this new spec under development. It's currently called RFC 217. It's not yet in the drafts and so on, but it's a spec under development. So how does it work? Well, JAX-RS resources are similar to servlets. And we already have this thing called the HTTP whiteboard, where we say publish a servlet as a service, and it gets picked up by the HTTP whiteboard. So we can just reuse this idea. Publish a service. It's a service of any type. This is the thing about JAX-RS resources. They're POJOs. So they have no particular they have no particular interface that they implement. So we have to publish them as a service of any type and add a marker property. So we add this property called OSGi JAX-RS resource.base, and it serves first of all as a marker to say this is a JAX-RS resource, and second it serves as a base URI, a base of the URI that we're building. And the code looks like this. So below the line here, we have the standard JAX-RS stuff, just a simplification of what I've already showed you with the at path. Up here we have the at component annotation, which is the declarative services annotation. So we say at component, service equals object, property equals OSGi JAX-RS resource base equals JAX-RS. So that's the property I already told you about. But what's this service equals object? Well, I said that this thing has to be published as a service. And a service has to have some type. But this component, foo, doesn't implement any interface. We'd normally publish as a service under an interface, but it doesn't implement any interface. But we still have to publish it as a service with some type. And it has to be a type that this thing actually extends or is. And there's only two options there. One is foo itself, and the other option is object, because everything extends object. And so we choose object here, service equals object. And by saying this, service equals object, we force BND to generate the service element for us. Otherwise, BND will say, well, this is not a service. You're not publishing as a service. So the path that you get from this, so if you were to now hit point your web browser at this thing, so we have the base path for the whole resource comes from example, comes from this property, sorry, which is example. The path here is foo, and then the path on this sub-resource is test. So you would go to HTTP host and port / example foo test, like that. A word about scopes. Now, in plain JAX-RS, these resource classes are typically created and immediately destroyed on every web request. And that doesn't match the standard OSGi service lifecycle. And that was actually a problem before OSGi R6. It is possible to do singleton JAX-RS resources, and that's what the OSGi JAX-RS connector did. But now we have the option in OSGi R6 to say that this is a prototype scope, and we do this by saying scope equals service scope.prototype, and that makes the JAX-RS resource component into a prototype. So just like a sort of a normal JAX-RS component resource, sorry, it will be destroyed and created and destroyed on each web request. You may not really need to do that though. The singleton is usually fine as long as you bear in mind that you may have concurrent access to that thing. One thing to bear in mind is if you are using a singleton, which is going to be the default, don't use injected at context fields, because that's obviously not going to work for multiple requests on a single object. But you can use these as method parameters instead. So I can pass at context HTTP headers to my resource method rather than having it injected into a field. We can cluster related resources into an application. The applications are provided in the same way with a slightly different property. So application.base instead of resource.base. Now, another very cool thing we can do, and this is the reason for the little and microservices at the end of my talk title, endpoint advertisement. So we've looked at how to create a JAX-RS service. But now let's look at the other end, the client. How does the client find your service? Well, the choices you might have are, well, first of all, I could hard code the URL to the service, which is obviously not very useful. Or I could manually configure the URL. But then, of course, I have to go out and reconfigure the box that has the URL that points to the service. Or I can do things with DNS, like dynamic DNS records, something along those lines. But we could also leverage the OSGi Remote Services spec. So OSGi Remote Services, just as a reminder, because this has been around for quite a while now, is a way of saying I'm providing a service here on one side of the network, and some magic happens between a remote services provider instance here, and the remote services provider on another machine is publishing a service, and this service acts as a proxy to the service over on the provider. So this has been around for a while now, and we can advertise these services, and they can be consumed by many places in the OSGi system. But you're not going to invoke a REST service in the same way as you would invoke a normal service, because it doesn't have methods. First of all, that's a bit of a problem. You can't call something if it doesn't have methods. So we don't actually use it this way. What we do is we're providing with the whiteboard an endpoint service. So an endpoint is an empty interface. It's a marker interface, but it has properties attached. And in particular, it has a property set that's called OSGi.JAX-RS.URI, which is a URI that can be used to access the JAX-RS resource. So in other words, what we're saying is from the thing that's providing a JAX-RS endpoint, we're also advertising to the network, hey, I've got an endpoint, and I'm on machine 10.2.2.1 / this URL. And that's advertised and can be picked up anywhere else that's subscribing to that OSGi Remote Services group. And it works like this. It's a kind of out-of-band communication. So the resource here provides the service, which has a property attached to the endpoint. That gets bound in and used by the REST client, but the REST client just uses that URL to connect directly by HTTP to the HTTP server. So the code snippet looks like this. So the component depends on the remote REST resource. That's a very interesting thing because I can say in my component at reference, now I'm targeting a particular endpoint here because I want a specific JAX-RS resource name. I don't want just any random JAX-RS resource. They're all HTTP something, but they do different things. But I'm saying here's my resource that I want to target, and I get injected with this endpoint and the properties attached to the endpoint. Now, I don't actually care about the endpoint itself. That's just there for the typing. But I can then use the converter to get hold of the OSGi JAX-RS URI property, and now I know the URI of my remote REST service. And so later on in my component, I can say, I can use the JAX-RS client API, say client.target, there's the URI that I got before, and .request. So I can make my REST invocation using the URI that I've been supplied previously. Now this is in an OSGi component, a declarative services component, and this component could itself be a JAX-RS resource. It could provide a JAX-RS resource as well. So what we see is we're starting to compose these things together. So this component is providing a JAX-RS resource, it's binding to other JAX-RS resources dynamically, not knowing in advance where they are. And it's got a temporal dependency as well, because this component will not be activated and it will not publish its service until the remote service with the name myResource becomes available. Once it does, this component will start and publish its own JAX-RS resource. So we start to end up with, and I tried to get this titled a bit shorter, but dynamically connecting and reconnecting self-assembling distributed applications. So if each of these is a JAX-RS resource, publishing a service, and they're dynamically connecting up together, discovering each other, then I can take one of these and I can kill it, or of course it could just crash all on its own. Doesn't necessarily need any help from me. It may crash. Well, just start it again. And I can start it again anywhere else, because once the new service comes back up, it will bind to the things that it was using before, that it wants to use, and it will provide its service and can be picked up by the thing that was using it. So it's reconnecting, self-assembling, self-healing.
Can you run redundant instances of one type?
Sure, sure. I mean, you'd have to deal with. I mean, typically these things are kind of stateless anyway.
Okay.
These resources tend to be stateless. Of course, they might be reflecting the state of something at the back end, like a database, but.
Yeah, if the state is only cached, then it's no problem.
Sure. Yeah.
One question.
Yeah.
Slide before, it had nothing to do with resource service administration.
Sorry, the slide or?
Yeah, this slide. It has nothing to do with remote service administrator, right?
It does. It does. So these are remote services. So it's a bit of a shorthand. The diagram, obviously, I haven't put in all the details, but this is a remote service. This is a DS component that binds to that remote service and provides its own service, and maybe the web browser is talking directly to this one. But again, this service, we're consuming it, but we're not invoking it directly as an OSGi service. We're just using its properties. We're then making an HTTP call to that. So if you want to code a client with this, we're supporting the JAX-RS Client Builder API. So that will be provided as a service. So anybody that's implementing this spec in OSGi will be providing a client builder as a service that you can bind to. And it's integrated with the OSGi promises spec. So what that means is I can say, so this bit here in the middle is standard JAX-RS client API from Java EE. We provide it with a so-called promise handler. We set up a couple of things. We target it, the URI, set a path, set some parameters, call an async request, and then get it with the handler. And then from the handler, we can get a promise. So this is a promise of a result. Now, the really cool thing about promises, and this is just an aside because some of you may not have used OSGi promises before, The really cool thing about promises is I can chain together a series of asynchronous invocations in a very fluent programming style. So I'm assuming all of these are kind of web requests. So find the map coordinates for a postcode, and given the map coordinates, find the nearest school using maybe some kind of government web service. And from the school, find the request, get the exam rankings for that school. So it's a very fluent API, and all these could be asynchronous. Okay, so a bit about the implementation that we have, and I'll give you a short demo. Thank you. So, as I said, RFC 217, you can view this on GitHub. So github.com/OSGi design RFCs/217. Coming out in OSGi release 7 around Q2, Q3 timeframe. The author of the RFC is my colleague Tim Ward from Parameterised. The RI is being developed by LifeRay based on the CXF implementation of JAX-RS, and it's an ongoing implementation happening in Apache Aries. It's still kind of limited, it's kind of pre-alpha, so the demo is going to be limited what I can show you, but let's do that quickly. So this is some code. My JAX-RS resource, I'm providing it as a component, as a service. I have two methods, say hello, which returns plain text, and another method which returns a book object. And book is being transformed to either JSON or XML by JAX-B. And the implementation of book is coming from this library service, and library is an OSGi service. It's not a JAX-RS service, it's just a plain old OSGi service which I've injected into this component. So if I run this, some output there, I'll go over to Chrome. Run that, and it says hello, customized for my current location. So that method worked. And then in order to call the other method, the findBook method, I have to specify an accept header to specify whether I want JSON or XML. Now, a web browser isn't going to do that for me, so I have this thing called Cocoa REST client. So JAX-RS example books 1234, that's my ISBN, and I can say submit, and I'm requesting JSON, and I get a response. There's my book information. Or I can ask for it in XML format. Oops, no, I didn't hit enter or something. I'll get it in XML format if I prefer. Kind of brief demo, but if you want to see more, you can go to Tim Ward's talk tomorrow, 10:15 upstairs. He's talking about transaction control, but his demo includes a CRUD microservice implemented with this spec as well. And that's it for me, so thank you very much. And do you have any questions? Yes, Marlon.